Today we're going to talk about constant speed. Some of the things that we're going to talk about today you already know, and then we're going to go and look at the equation. Pretty much all the stuff you already know, so we're just putting it all together. All right, so what do we already know? We already know that, like, the definition of constant speed is when you are traveling the same distance per time unit. Okay, so if you're traveling 5 meters per second, that means that you're going 5 meters every second. So 1 second later, another 5 meters, another 5 meters. So you're going 5 meters every second. We also already know that that means that when we make the little dots like we did on our video, that those dots are equally spaced apart. So like this would be our dots right here. And our dots would be equally spaced apart. We also already know that a distance time graph makes a straight line, and the slope of that line is our velocity. Okay, and just to see how that works, our distances are in meters, our times are in seconds. So when we find slope and we do our change in y over our change in x, that's what that little triangle means, change in. We have our meters, our change in our meters, divided by our change in our seconds. So look, that's the unit for velocity. So we know that you can have positive and negative velocities. Okay, a positive velocity is when you are going away, and that's a positive slope. And a negative velocity is when you're going towards, and that has a negative slope. Look at all this stuff we know already. We have learned a lot so far. What else do we know? We know that the velocity time graph is going to give us a horizontal line because we are going the same speed. So if I'm going 1 meter per second, I'm going 1 meter per second the whole time, no matter what my time is. So that's how it comes out to be a straight line. And faster is further away from zero. So this is faster, this is slower. And a negative speed, this is also faster, because I'm the same distance from zero. So this could be 3 meters per second, and this one down here can be negative 3 meters per second. The only difference being the direction. So this one's going away because it's positive, and this one's going towards because it's negative. See all this stuff we know? We're just, all right. So then we actually know more than we think we know. Remember from 6th grade, you had distance equals rate times time. Okay, that distance is your distance traveled, so that's your meters. Your rate is your constant speed, or it's your average speed. Okay, because sometimes we are not going at a constant speed, but we can average our speed. So both of those work, and this is your time. Okay, so one of the things we need to make sure is that the units in our rate here, the units in our rate have to match the units in our distance and the units in our time. So if our rate is in meters per second, then our distance is in meters and our time is in seconds. If our rate is in kilometers per hour, which it could be, then our distance needs to be in kilometers and our time needs to be in hours. So you just need to make the conversions, and it doesn't matter which one you convert, but you need to make the conversions so that your velocity unit matches your distance and time units. But 6th grade, look, already gives us the equations we need. So from 6th grade, we had distance equals rate times time. Well, our book is going to call distance x, and it's actually going to call it displacement. So it's going to be the final minus the initial, how far you went. So this distance is how far you went. And that is the difference between your starting position and your finishing position, or your final position. Let's call it final. Okay, so remember, Jesus said, the first shall be last and the last shall be first. The first shall be last and the last shall be first. So it always goes final minus initial whenever we're finding change in anything. So that's our distance, and that's going to equal our velocity times our time. Okay, but it's still, the equation is still distance equals rate times time. It's not different. It's the same equation. They just substituted in different variables. And then what we're going to do is this, and we're going to move that x initial over to the other side. So our x final, meaning our final position, where we end up, final position, is equal to vt plus our initial position, where we started. Okay, but again, it's still versions of distance equals rate times time. So it is not necessary to memorize all these different formulas as long as you understand distance equals rate times time. If you understand how all of these other parts here go into distance equals rate times time, that's really the only equation needed for constant speed. All right? So we're going to apply this in our book problems. Have a good day.